Okay, how can I solve this question? Basically, you are given a linked list. 2, 3, 4, 5, 6, 7, 8, and 9. Okay, the first basic approach is like detecting the loop in the linked list. So basic approach, I can solve this question, but it will destroy your linked list. So it is not preferable, but I'm going to like explain that approach. The approach is like I have to create a dummy node. The dummy node is like value, let's say anything, but what is value is this pointing null basically. So I need to check like while I'm traversing at each node one by one. While I'm traversing on one, I need to like remove this linked and pointing to this. Okay, and one more thing, I need to create a next pointer also, because I need to, while I removing this, I will lose this connection. So I need to go forward. So how can I go forward? I need to take next pointer also, which name is L, let's say. Okay, this is my current pointer. So what can I do while I pointing to this? I need to move forward. Okay, both of the pointer. My current is here and my next is here. Okay, again I need to remove this connection and pointing to this. And for all these cases, I need to do this. While I am here, I need to remove this connection. I pointing to here. My current now is here and next is here. While removing this, I need to join this connection. Okay, move forward. I am here. Okay, my current is here. While I am moving, I already removed this node. Okay, because I am here, I already removed this node. Okay, now while I am pointing, it is already pointing to this. While I am checking that, it is already pointing to that node. So I can say from here that there is a loop is here, because I already done this step for this node. So I clearly know that the loop is present here. So this is the basic approach, but this will destroy your linked list. It is not preferable. The time complexity of this solution is big O of n, and space is O1, but it is not preferable to solve like this. If you ask in an interview, you can say this approach also, but it is not preferable. Now I need to forward one more approach, which is also not preferable. I'm saying I'm explaining why that also not preferable. So let's say take that same example. Okay, 1, 2, 3, 4, 5, 6, 7, and this is coming to this. Okay, the next approach I can use like a hash map. Okay, in hash map in Java and another map in C++. So I can say while I traversing at every node, I need to create a map also with that element. Okay, while I am at one, I need to check. I am visiting one and I am creating the second value pointing to the one. Okay, and going to next element, again put pointing to one, that node. Okay, this is basically map I am using. Okay, while I am here, I also put this in the map. At last point, I am done this all same step for all the cases. At the last point, I am doing this step. While I am coming again here, I am checking whether I visited or not this node. I can clearly see I visited already. So this returns me true actually. So I can say from here that I already visited that node. So I find the loop here on this point. Okay, so In ordered map, I can check whether element is present or not in O1. Okay, so write down the, I'm writing the complexity of the complexity. I'm iterating at the one time of the whole linked list. So the time complexity is O1, and checking for all cases, I am taking also O1 time space. So I can say that the time complexity in this algorithm is taking big of n. Okay. So I'm saying, but the main cause is here is like I'm using big of n space also here, which is not also preferable. Okay, I need to do this question is shortest, like minimum bound complexity. Okay, so that space complexity is here for big of n. So this is not also preferable. The most efficient method I am going to say after this method. I hope that this method you have got. I done this method. Okay. Now I am going to the most efficient method, which is like float cycle detection method, also known as. Okay. This method is very important actually. It is using in many of the questions. Okay. Let's see. I have let's say in English 4, 5, 6, 7. So this is particular 4. Okay. So in this method, what I am doing that I need to create a start point and like not a start. I can say that slow pointer and fast pointer. While I am using this slow pointer and fast pointer and explaining after that, what I am doing that while I am iterating, I move my slow pointer as one step and my fast pointer as 2 step, like this. I am not staying here, but I am just moving and directly moving on the second node. Okay, from like while I am iterating, I am moving like this with my slow pointer and my fast pointer is like this. Okay, while I am here, my slow pointer is here, my fast pointer is here. While my slow pointer is here, my fast pointer is again here, and again my slow pointer is here, my fast pointer is here. My slow pointer is here, my fast pointer is here. Okay, and again while I am here, my fast pointer. What is my fast pointer? There, here is my fast pointer. And then I meet at the same point. So while I meet both of the pointer at any of the point, okay, while like slow pointer equals to fast pointer, then I can say that the loop is present in the loop is present in that linked list. I am explaining how this is possible. Okay. Let's say you are given a linked list like this. Okay. Now, how can I say that the pointer will meet at some of the point? This is my slow pointer. This is my fast pointer. My slow pointer moves like this. Okay. My fast pointer is. While they both are like entering in the loop, my slow pointer is like my fast pointer is moving like this, and my slow pointer is moving like this. Okay, at any of the point, it can take any number of like iterations of the iterating the loop, but at any of the point, it will definitely meet. Okay, while I'm like moving this, you can understand it, like you can imagine that thing. Okay, while I'm moving one by one step, and my fast pointer is 2 step, at any point of time it will definitely meet. So this is the basically intuition I am trying to explain that, and it is taking also the minimum number of loops which is needed, like 1 and 2 and maximum 2 and 3. Okay, while the size of the linked list is not bigger, like size of the loop also is not bigger. It will definitely meet in 1 and 2 loop. Okay, so this is the like what I'm trying to explain. uh, one more thing is that like how can I remove that like how can I remove that loop? Okay, so I'm explaining that step also. Let's say I have a thing like this. A slow pointer is here, a fast pointer is here, fast pointer is here also. Let's say they both have slow pointer and fast pointer meet at this point. Let's say I say this A and this distance is B and this distance is C. How can I like find that element that node which the both like not both but the loop is starting? How can I find that point? Okay, I can say that like I right now I am giving like I am saying that they while I'm starting my slow pointer from here and my one more I am taking one more pointer from here. Okay, while I am moving one by one here and one by one here, I definitely reach this point. I'm explaining why this is happening like this true. Like these distance are same. Definitely they are same. No, this is A, so I can say that this distance always are A. I'm explaining why this is true. Let's say this is A, this is B, and this is C. Okay. Let's think like while they are reaching at that point, I'm assuming that the slope undertaking m loop traversing. Okay, and the fast pointer take n times like traverse the loop and then they are meeting. Okay, how can now I explain why they are the distance of this one is equal to the distance of this. Okay, I'm explaining that point. Let's say this is A. Like how much the slope pointer travels the distance. Okay, slope pointer at here after m number of loop iteration. Okay, so I can say from clearly here this is traversing m loop. So I can say, and one more thing, like slope pointer is moving one step and my fast pointer is moving two steps at a single time. So how can I like one more like thing I can say from here that distance traveled by the distance travels by slope pointer multiplied by 2, the distance traveled by equals to the fast pointer. This is also true. Okay, so I'm writing the equation from this method, not method but this relation. Okay, using this relation how can I write that distance traveled by slope pointer? What is distance traveled by slope pointer is, this is A. Let's say m is loop iterations, slope pointer takes m into in one iteration how many distance travel b plus c. Okay, this is multiplied by 2 equals to distance traveled by fast pointer. What is the fast pointer distance? A plus n loop traveled by fast pointer. What is the distance of one loop? B plus c. Okay. Oh, one more thing here. Okay, one more thing, like they are reaching at this point now. After iterating m loop, the slope pointer, it is also traveling the b distance also. I need to add the b also here, and here also I need to b distance. After solving this a plus b, 2 times of a plus b and 1 times of a plus b, it is remaining as a plus b at a single time. And from here I can say b plus c while taking common. I'm taking this m is here, and after solving, this is coming. Let's say this is a constant. This is also constant value. Let's say this is lambda, not lambda. Let's say anything. Let's see. No, see. I need to take a lambda over here. Okay, because I have taken all the variables previous before. So after taking lambda times of b plus c. Okay, let's say the lambda is 1 is here. The lambda value is 1. Okay, so from here, while taking the lambda is 1, okay, what can I say that a plus b equals to b plus c. So after solving this equation, I can say that a equals to c. So I proved that the c distance is traveled is equals to a distance. Let's say lambda is taking, we will take the lambda to value 2. Then what will happen? That is also true. I am explaining how. Okay, so here I can see is lambda b plus c. Let's say lambda is equals to 2. Here, what is the value? Plus b 2 b plus 2c. What is the value? From here I can see a equals to b plus 2c. So I can write this thing. Let's say I'm arguing the linkage. I mean here, this is a distance, this is b, this is c. This is c actually. So how can I say that this is also the same, like I can say a equals to c. So I can write this thing as like b plus c plus c. Okay, what is b plus c here? The one loop length. Okay, the b plus c's value is here one loop length. So what is signifies that the distance of a, and while I am entering from here, I traverse one loop, that is length of b plus c, and okay, and this length. Okay, I'm again like I'm here, and I like traverse one loop from here, and after reaching here, I'm moving c length. Okay, so the c length is also here. I can say that the b plus c, after what is b plus c? The loop length. This is basically loop length. So I can say that the c length is equals to a, by like removing this, because I am again reaching at this point after traversing one loop. Okay, so I can simply remove this thing. So I can say that a is equals to c. So this is the basic concept. How can I reach at this point while after detecting the loop from like Flood cycle algorithm. So I explained the code in the code section part in my laptop. Okay, and okay, this is basic concept actually. This is need to like remember. This is you need to remember. This is very important actually. So can I write the code here? Okay, I am writing the code here, not writing on laptop. I'm writing the code here. Like not a proper code, but I'm writing a little bit small type code. Okay, let's say draw the linked list also. This is my starting point. Let's say I'm meeting slow and fast pointer. Let's define the slow pointer. Let's say the way I am creating the slow pointer is using head. This is basically head mode. You are given in the function my first pointer is, what is my first pointer is also same as here. Okay, let's say no, keep the same. Now I am traversing one by one. Okay, while my fast, because fast is reaching first of all in the null part, no? That's why I am taking the fast pointer, otherwise it will give segmentation fault. The fast is not equals to null, or okay, I need to check, like I need to write one more condition for this. I am explaining why I am writing that condition. Let's say take a example like this, 1 2 3. Wait, my fast pointer is here. How I am moving my fast pointer? I'm here. At that point, I am not at the end node, but I am not at the null pointer, but I am at the end node. So from here, if I will move, it will give me segmentation fault. So that I need to add one more condition while my current, like my fast pointing to next is equals to null. Then I also break my while loop. Okay, so I need to give this condition also. If fast is equals to null, not equals to null, and fast pointing to next not equals to, then I only traversing. Okay, what I am doing basically, if my slow pointer equals to fast pointer, then I need to simply return from here, which is true. Okay, at every point of time I need to increase my slow pointer by one step, slow while taking next, and my fast by two step, fast pointing to next, pointing to next. So this is my detecting loop code, and after I am not returning the true, then I also return false. Like also I must have to return false if I not getting any loop from the linked list. Okay, this is basically code of the checking if loop is present or not in the linked list. Okay, now I'm going to write the code for the how can you find this node after checking the loop is present in the linked list. Okay. In the previous code, I mentioned that while I am reaching at this point, I need to return, but I am not returning at that point while I am finding this node. I am not returning at that point. Just break the loop at that point. While I am reaching that point, I am just breaking the loop, and I get the slow pointer and fast pointer at same point. So what is slow pointer? I will get after detecting the loop. The slow pointer I will get after that. Now I am going to again one thing. I need to create one more pointer at this point, like dummy pointer, which is head also, not null, but which is head also. Okay. After that, I am iterating it one by one step. Why? My dummy is not equals to my, let's say, my slow pointer. I'm iterating one by one step. Dummy equals to dummy by next, So this is how I can find this node value. One more thing I need to do. Let's say I need to remove this loop. How can I remove this loop? Let's say take a number 1, 2, 3, 4, 5, 6, and this is the loop here. So how can I remove this loop? Like I am starting my slow pointer from here, and my fast pointer is also from here. I am iterating through this linked list while I am here. While I have my slow pointer here, my fast pointer is here. While my slow pointer is here, my fast pointer is here. My slow pointer is here, then my fast pointer is here. Okay. Sorry. I aim to an interval. I forgot where I am. While I am slow here, my fast is here also. While my slow is here, my fast is here. While my slow is here, my fast is here. While my slow is here, my fast is here. Okay. While my slow here, my fast is here. While my slow is here, and again I meet this point, this slow pointer and fast pointer. So how can I remove this loop? I can do the same thing here, but I need like one more thing from here is I need to I need to take a pointer which is giving my previous pointer. Okay, let's say my previous is null, starting from here. Okay, while I am moving one by one, I need to my previous pointer as current pointer. While I am here, my current pointer is here. Like I am taking the dummy pointer. While my dummy is here, my previous pointer is here. Okay. I am not taking this pointer. I am just taking this pointer for this previous. The previous I am defining for this is null from here. Okay. So after that, while I am here, I need to my dummy pointer is here. While I am here, my dummy pointer is also here, and I am giving my previous as current pointer. This is pointing to this right now. While my slow pointer is here, my slow pointer is here, my dummy pointer is here. Not dummy, but previous pointer pointing to this point. Okay, while I am reaching the slow pointer and the dummy pointer at the same time, same node, what can I do? I can do my previous pointing to next, removing this, but I can do my previous pointing to next as done. So this is how I can remove the loop from the linked list. Okay, I can write the code for this also. Okay, let's say now start and creating the previous pointer which is in starting on null. Okay. Okay, this is fine. I am iterating the loop while the same loop. My dummy pointer is pointing and starting here. My slow pointer is pointing starting here, and my dummy pointer is also null. Not null, but and I am iterating from here to my while loop while dummy is not equal to slow. I need to move one by one. Okay. Like dummy equals to dummy pointing to next, and I am giving my previous pointer as my slow pointer, and increasing my slow pointer also slow by next. Okay. After running this loop, I am getting my previous node and my both of the dominants point to this node. I get the previous node from here. So what can I do from here is a previous pointing to next equals to null. So after writing this step, I will remove. I was removed the node like the loop from the previous case. So this is basically intuition. I am trying to explain this for this person, and this whole algorithm is called as Floyd algorithm. You need to remember this algorithm. This is the most important actually. Okay, thank you.